Welcome. I always enjoy settings like this. I'm Dr. Albert Mensah of Mensah Medical, co-founder, and my partner, Dr. Judith Bowman here. Judith, stand up for a minute. Also co-founder of Mensah Medical. We enjoy these settings because there's so much anticipation about learning what is new. And the interesting thing about us as physicians in this world is that we get so stuck in what it is that's old. We stop being what was originally designed by the term physician, which was an individual who would seek to explore, to learn, to grow, based upon a scientific foundation of what it is that we already know. And unfortunately, probably a good 60% of us in this field are not doing that. We've become practitioners as opposed to physicians. But here at places like Autism One, we get a chance to see a lot of the people who are still doctors and who are scientists working to move better. How many of you have ever experienced going to a doctor and saying, well, my child has a particular issue and that doctor has never heard of it, or heard that there was a treatment for it, or understood the relevance of it, or maybe you were told, I'm sorry, but they're going to be that way for life. I'm sorry to hear that, but that's why you're here. These are some of the common difficulties about the practice of medicine. We run typically about 50 years behind the latest advances. And so many folks like you, and really us as well, we're pushed into the realm of pioneers, and that's what you all really are. Because what you're learning these days hopefully will be commonplace in the next 20, 30 years. You folks are really the people who are pushing the doctors to learn, to change. Because the more and more they hear about these concepts, these ideas, these treatable phenomenon, the more, quite frankly, their ego says, maybe I better investigate this because my patients know more about this than I do. And so it becomes an entirely different paradigm. One of the things I was talking with my mentor about was that he felt that change would come from other sources. And I said, no. I said, change is going to come from the people as they push their doctors. So please keep on pushing. I'm Dr. Albert Mensah, and welcome. Mensah Medical, we have a clinical experience in terms of all that we've looked at as far as patients are concerned. We have 10,000 ADHD and behavior patients in our experience, 4,600 autism spectrum disorder patients, 3,500 with schizophrenia and bipolar, and 3,200 with depression. Next slide. Let's talk about the history of autism. This I always find to be most interesting and at the same time rather disturbing. Back in the early 1900s, autism was referred to as a range of psychological conditions, including schizophrenia. In the 1940s, autism was used to describe children with emotional and social problems, and that's when Asperger's syndrome was identified. In the 1960s and 1970s, treatment relied on pain and punishment. I don't think that worked too well. And then psychotropic medication like LSD. In the 1980s and 1990s, behavior therapy came about, and highly controlled learning environments became the primary treatments. Today, research and treatment focuses on both genetic and environmental factors, behavioral therapies, and dietary changes and more. Next, please. Now, how many of you do not know what's up here? Autism is treatable, and recovery is possible. Is there anyone in this room who does not know that or believe that? You're doing better than about 90% of physicians around the world. Did you know that? Sad to say, but true. Next slide, please. Let's talk about some of the variables here. What we're going to do today is we're going to look at the big picture as to how you approach the treatment, the evaluation, the discussion, and then for guide therapy as far as autism and autism spectrum disorders are concerned. Now, I'm going to say one thing that's not on the slide. We mentioned Asperger's syndrome earlier. Do you guys understand, and maybe many of you don't, that autism and Asperger's are not the same thing? Does anyone not know that, or have you heard differently? Really? Good. Things are really moving along faster and faster. They're two totally different entities. Their biochemistry is different. Their brain structure is different. And quite obviously, the capacity for intellectual development, change, and future prognosis is absolutely different at its core without treatment. Okay? But the brain is a biochemical factory, which means everything that you really need is either made, acquired internally, turned around, and then processed. It doesn't just sit there ready and waiting to be used. That's called a waste of time and energy and resources. Your body's highly efficient. Neurotransmitters and neurological inhibitors such as serotonin, dopamine, GABA, which we call gamma-aminobutyric acid, are critical, absolutely critical to brain function. These are the chemicals that allow nerves to communicate. Serotonin, dopamine, and other neurotransmitters are made in the brain from vitamins, minerals, and amino acids. I want to pause there for a second. You ever go up to your physician or your healthcare provider and say that you want to start a regimen of nutrients? We're having people laughing. Now, what do they typically say to you? That's a waste of time. Save your money. Snake oil. Now, I have a confession to make, brothers and sisters. I was one of those doctors. I had on many occasions patients come up to me and say they wanted to do that back in the old days, and I said, you go right ahead. You're wasting your time, wasting your money, it's unproven, it's unfounded, it's blah, 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 blah. And yet, I stand before you here today talking about this, so something must have happened in between. We'll talk about that later. We look at genetic or epigenetic imbalances in nutrients and how they can actually alter brain levels of key neurotransmitters and result in abnormal brain chemistry. What this really illustrates is that about 30, 40 years ago, when our co-founder, Dr. Carl Pfeiffer, actually a brilliant MD, PhD psychiatrist, discovered all of this, we thought the key issue was around neurotransmitters. And that's the same thing that the pharmaceutical industry did. Pharmaceuticals are based upon manipulating neurotransmitters. And basically, we stop the destruction of neurotransmitters. But what we've come now to see is that these elements that are key really revolve in what it is that causes a neurotransmitter to be produced. And what causes a neurotransmitter to be produced effectively is not just enzymes. It's the vitamins, minerals, and nutrients that go along with those enzymes. And they're far more powerful in this process than the enzymes themselves. When we have a genetic or an epigenetic imbalance, it can alter nutrients, and this therefore will alter brain chemistry. By understanding biochemical imbalances in autism, advanced nutrient therapy really sort of aims to normalize a child's body and brain chemistry, reducing inflammation as well as oxidative stress. Is there anyone here who's not heard of oxidative stress? Be free, raise your hand. Very good, ma'am. Oxidative stress is what happens at a cellular level. My partner, Dr. Bowman, likes to talk about rust. Does anyone here not know what rust is? Anyone here own a car? Anyone here own a nail? Ever been left out in the rain? It turns into a corrosive, distorted element that is no longer functional. That's what oxidative stress does. It produces inflammation. It turns your cellular tissue. It turns your entire system into one creature that is sitting basically on top of a low flame. Do you guys remember that old commercial? Some of you may remember it. It says, this is your brain on drugs. You crack the egg in the frying pan. That's what I say oxidative stress is in your system. Okay? It is slowly cooking your brain and many organ systems in your body. And it's done at a cellular level. Now I want to explain cells for a minute. Does anyone not know what a cell is? The smallest functional unit we talk about. Lots of cells make tissues, lots of tissues make organs, lots of organs produce all the books that we talk about, gut and psychology syndrome and all that other fun stuff. Well, each cell has at its core a very central processing area we call a nucleus. In the nucleus is where we have our DNA, the blueprint that we really need to work and function. But it requires a normal body structure, normal structure, in order to have nutrients, vitamins and minerals, going from the inside to the outside and back and forth and vice versa. These things are extremely important. Now, when you have oxidative stress, ma'am, oxidative stress impedes that process of the movement of these ions, of these minerals, these nutrients back and forth, which means you now distort the cellular ability to function appropriately. And then there's an exponential effect throughout multiple systems that causes major problems. Next slide, please. Let's look at our evidence-based research as far as our autism spectrum database is concerned. We see very striking biochemical differences between autism children and non-affected children. And that was determined by Dr. William Walsh, PhD, mentor and friend of the original Pfeiffer Treatment Center. We had about 90 to 150 assays of chemical factors in blood, urine, and hair for each of about 6,500 patients. More than 800,000 chemical test results were acquired. We saw that in spectrum patients, they exhibited biochemical imbalances that were far more severe than even with patients who had violent behavior. When I say violent behavior, I mean the sociopaths, the psychopaths that we'd like to watch in the movie theaters, the Hannibal Lecters. The intensity of the biochemical imbalance effect in an autism spectrum child is greater than what Hannibal Lecter experienced. Isn't that something? Huge. So there's a little bit of a real sort of intense need to kind of get this under wraps and to handle this situation. Our autism patients exhibited biochemical imbalances. Oh, we already talked about, sorry. Discovery of undermethylation was a huge, huge, huge phenomenon. Anyone here ever heard of the MTHFR test? Very good. Anyone here ever heard of the 23andMe test? I'm going to give you a little bit of trivia to go home and tell your friends. Those two tests really would not have come about if it hadn't been for Dr. Walsh, PhD. Dr. Walsh brought the concept of undermethylation to the autism community at a think tank session back in 1991. It was those individuals at that think tank session that then began this whole process of evaluating genetic issues and genetic hopes for finding the cause and therefore the treatment. All of that from this concept of undermethylation. Now, what is undermethylation? First, let's get that clear because there's so much stuff on the internet, and that word is so heavily used, and most people don't even know what it really means. A methyl molecule is simply a carbon atom with 4 hydrogen atoms. Very, very simple. It's one of the basic things that we use in organic chemistry. You know it as far as barbecuing is concerned with propane. It's made of multiple methyls. Ethanol, some of you may be familiar with that. It's a couple of methyls. But methylation is when you take this methyl molecule and you add it to another molecule. Now, when you add something to something in chemistry, it usually changes not only the structure, but the function. And that's what methyl does. Methyl either stimulates or turns on or turns off different enzymes, hormones, or neurotransmitters in your system. So remember we said the brain was a factory, and I said that not everything is just made ready to go. Everything is made sort of packaged and then dormant until something comes to activate it. So when we talk about methyl, and you hear the word methylation, the first thing I want you to think about is a key. In the old days, we actually had keys to turn on cars. We didn't have start-stop buttons. Okay. But when you had a key to unlock your house, you turned it, and you had something happen. The door opened. You put the key in the ignition, the car went on. You put the key in the ignition, turned it the other way, the car went off. That's what methyl does. It turns on your enzymes, hormones, and neurotransmitters. How many of you have ever had serotonin levels evaluated on biochemical testing or neurotransmitter levels? Very good. Now, what's interesting is that we had the presumption that just because an enzyme or hormone or neurotransmitter was present, that it was working. Okay. Until we started looking at methylation, we didn't realize you could have all the enzymes and neurotransmitters in the world present, but if they're not turned on, they don't do you any good. So looking simply at neurotransmitter levels is not going to be the key to revelation. It's not going to be the key to understanding, and it's not going to be the key to treatment. How many of you look at a parking lot full of cars? I love cars. I'm sorry, I have to admit that. Look at a parking lot full of cars and assume that every single car there is equal in function. Do you buy the car just by saying, well, there it is, I'm just going to pay for it? I'll put the key in later and try it out at a different time. You say, no, I want to test drive that car first. I want to make sure it works. Well, in our system, just by looking at neurotransmitter levels, we don't know if they're active or not. But looking at methyl concentrations, now there's something interesting. Because if you've got enough methyl, it's doing the job it needs to do. If you don't have enough methyl, it's not able to do all that it's supposed to be doing, turning on and turning off. In other words, regulating enzymes, hormones, and neurotransmitters. So now that's the concept of methyl. And now methylation is the process by which we add a methyl molecule, that key, to an enzyme, a hormone, or a neurotransmitter. So now when you go to get that genetic test, and they're saying, well, the odds are you're undermethylated, now you have an idea as to what that really means. You don't have enough of the structural elements to turn on those enzymes, hormones, and neurotransmitters. But here's some of the questioning and some curious concepts. If there's undermethylation, can there be overmethylation? Now, how many people here have heard of overmethylation? Beautiful. You guys are advanced. Wonderful. But you know what? We don't have any tests for overmethylation. Did you know that? We don't have a single test that is genetic in nature to determine overmethylation. In other words, part of the problem with regard to the testing that we have right now is that it is more biased towards delivering a falsely positive result for the concept of undermethylation. In fact, most of these genetic tests actually really don't tell you about undermethylation. They tell you about the possible activity of one enzyme out of 15 or 20 major enzymes in the process of methylation. And it's just guesswork, basically. It's a qualitative, at best, assessment. What we use in our world is a simple blood test. A whole blood histamine test actually measures concentration of methyl. That's the end product of all this discussion and fighting between enzymes for undermethylation and enzymes for overmethylation, and the sum total is simply methyl. That's what you want to know, how much methyl is made. I digress. Let's go to the next one. Distinctive features of autism. Number one, there are very severe biochemical imbalances. Number two, incomplete brain development. Number three, a strong genetic predisposition. Number four, onset after an environmental insult. Now, many of you may be thinking, hey, wait a minute now. My child was born this way, or I know a child who was born this way. The environment doesn't necessarily mean the outside environment. What is going on in the womb between day 16 and 24 of pregnancy? How many women knew they were pregnant between day 16 and 24? You guys are really amazing. Most women don't know that. Now, I know some women say, I knew the moment that my child was conceived. I felt it. A very interesting reaction. But most don't. So a lot of things are still going on to affect the environment of the womb, and it's those critical 10 days that can change the lives of hundreds of people. That is, the child and everyone that child is associated with. So an environmental insult, even at the level of the womb. High oxidative stress, one of the things that we talked about before. And then the gut-brain connection. Let's go to the next slide, please. Let's talk about oxidative stress in autism. Excessive oxidative stress is evident throughout the entire autism spectrum, period. The oxidative stress model actually can explain most of the symptoms of autism. Very few models of autism can actually do that, but oxidative stress seems to go there. Most autism therapies have extreme antioxidant properties. Oxidative stress has become a leading focus of autism research. I want to talk about chelation for a moment. Anyone here ever heard of chelation? Oh, that's a big number. Okay. And I'm going to say something a little bit different for you folks. We don't agree with traditional methods of chelation. The reason is because it strips the good metals away as well as the bad metals. And that actually causes a functional challenge. And I know what you're hearing, I know what you're going to say, but Dr. Mensah, my practitioner said we need to take this stuff while we strip that stuff away and it gets back and everything is okay after that. Well, no, not exactly. For example, zinc. When you strip zinc from the system, and zinc is a key metal with regard to neurotransmitter development and regulation. When you strip zinc, it takes 3 months to rebuild back to the original concentration, that level of zinc. So what do you think is happening to the rest of the system of the child while that zinc is in process of trying to slowly get back to where it was before 3 months earlier? Immune function is regulated by zinc. Growth and development is regulated by zinc. DNA is highly influenced by zinc. So there's a bit of a challenge there. And I'm going to go back to a different concept with regard to how to remove metals from the system that doesn't involve that. Why do you see a positive benefit for about 2 to 3 months with chelation? The reason is that many of these chelating agents are very strong antioxidants. They have a tremendous antioxidant burst. So that child that is seemingly deficient and under tremendous oxidative stress, that fire we were talking about, gets put out pretty quickly, or so we think, by these chelating agents. But it's put out maybe this much. Not entirely. Because those flames flare up again, and that's why you have to chelate 3 months later. And then many practitioners will tell you, well, yes, but you reaccumulated those metals, and so we had to do it again. Well, what about the third round of chelation? Did you reaccumulate all those metals just that quickly, back to such severe levels? Folks, I got to tell you, it doesn't work that way. All of us in this room have metal accumulation, okay? The question is, how do we detoxify them, and how well do we cope with them, and how difficult and how much oxidative stress are we under? But traditional methods of stripping the body of these bad metals is not what's actually causing the problem or fixing it. The key here is dealing with the oxidative stress, and that's partially what happens with traditional chelating elements. Next slide, please. Let's talk about some of the biochemical abnormalities that we see in autism. We see a depressed glutathione and cysteine concentration. And what is glutathione? A very powerful antioxidant, extremely powerful. We see elevated toxic metals. So we're not saying toxic metals aren't part of this, they are. It's just how you deal with them is a whole other issue. We see a depressed SAMe-SAH ratio, and what that really is talking about is the concept of methylation once again, and a measure for methyl. We see high copper and low ceruloplasmin. Folks, copper is an extremely toxic element. Every one of us needs copper, but we need it only to an extent. Most of the individuals in this room are females, and unfortunately, many of you have probably suffered from copper toxicity and didn't know it. Anyone who's ever had anxiety and depression on top of fibromyalgia or chronic fatigue syndrome or irregular menstrual cycles, hemorrhagia, cysts, the question is, did you actually have copper? This young lady sitting up here, Dr. Judith Bowman, worked with Dr. Walsh in a pioneering study on the effects of copper in females in postpartum depression and postpartum psychosis. We found that a good 85 to 95% of the females who had postpartum psychosis and postpartum depression were singularly copper toxic. Remove the copper, the depression was gone. Now, folks, that's in a fairly healthy individual who's got basically just cognitive issues. Imagine what it's doing in the mind, in the brain, and the body of an autistic child. Huge. Depleted zinc and metallothionein. Metallothionein is a protein in the brain that acts like a policeman. It sort of surveys the land of the brain all day long, 24 hours a day, and decides whether or not good metals are present, bad metals are present, and then it takes away the bad ones and puts in the good ones. It's a regulator of metals, and that's one of the key elements we use in our treatment therapy to deal with autism and metal dysregulation. Pyrroles. Anyone here not heard of pyrrole disorder yet? Wow, more than I thought. This is the buzz on the internet now. Google pyrroles when you get home, and then pay attention to not half of what it is that's being said about it. Okay? Pyrroles are molecules that in the body are part of the red blood cell structure. So everyone has pyrroles. But after 120 days, when red blood cells die, these pyrrole molecules break off, and then they change their structure under oxidative stress. They change their structure, and now they become sticky. They're looking for key elements that are called aldehyde molecules. They're looking for zinc and vitamin B6. Now, what's important about zinc and vitamin B6? I got to say this quickly. They are responsible for making your serotonin, your dopamine, your norepinephrine, and your calming neurotransmitter gamma-aminobutyric acid. So if you've got an element that is a thief in the night, that steals your zinc and B6, you cannot make your neurotransmitters in a balanced fashion. If you can't have balanced neurotransmitters, you don't get balanced communication of nerves in your brain. So how on earth can you possibly think straight? How do you expect to have an emotionally calm situation? You can't. When pyrrole molecules are elevated, your system is depleted of the very things it needs in order to maintain what we call homeostasis, or balance. Now, children with autism, usually have quite elevated pyrroles. Pyrrole molecules are also a sign of oxidative stress and inflammation. So we expect that anyone under oxidative stress has tremendous levels of pyrroles in terms of intensity, and it's treatable. We often see low vitamin B6, low vitamin C, and selenium. Folks, selenium is a very important element. It is a metal, but it is a very powerful antioxidant, as well as a wonderful helper to regulating metal. However, don't go home and take some selenium on your own. That stuff has a very narrow therapeutic index between usefulness and toxicity. Yes, nutrients can be toxic. Does anyone here not know that? Please don't do this at home. Consult your local professional advisor before you do anything on your own. Elevated urine isoprostanes. We'll skip that. We'll come back to it. Next slide, please. The critical role of methylation. Excessive nutrient overloads and deficiencies disrupt methylation pathways. Now that you're all experts on what methylation is, you know that nutrients are going to affect this in a very negative fashion. The body's methyl groups turn on genes or turn them off literally by affecting the interactions of DNA. See, now we're getting down to the nitty-gritty. Between the DNA and the cell's protein-making machinery. DNA gives the orders. The machinery makes the proteins. Methyl challenges affect that communication. Okay? So very, very key interaction. Because the methylation cycle is essential for mental and physical health. Basic nutrients necessary for normal function of this cycle are extremely critical. Too much or too little of important methyl groups can cause a methylation imbalance. That's why I asked you if anyone was aware of the concept of over-methylation. Because it's not just under-methylation that's a problem. Next slide, please. Methylation impacts every important organ function, from balance to blood pressure to pulse to respiration, gastrointestinal issues. Anyone here ever heard of gut problems? There we go. And urinary tract infections. Overmethylation. We measure overmethylation by having low blood histamine test results. Histamine is actually a reflective marker of methylation. They have the exact opposite relationship. When histamine levels are high in the blood, methyl is actually low. It literally suppresses methyl. And methyl does the same. When methyl is high, it suppresses histamine. So a simple blood test actually tells us how much methyl is present. And that's what we want to know. That's what determines if you are an undermethylated or an overmethylated, not a genetic test. Okay? How much methyl, that's what needs to be measured. Undermethylation, where we see elevated blood histamine, is associated with OCD, oppositional defiant disorder, seasonal depression, perfectionism, competitiveness. By the way, many of us are undermethylators. I believe my colleague, I won't tell you which one, but I believe she's an undermethylator. They tend to be perfectionists. They tend to be very great students. They become great graduate students. They become the Ds, the MDs, PhDs, JDs, educational doctorates, teachers, IT people, blah, 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 blah. List goes on. They tend to do very well. Asperger's individuals tend to be predominantly undermethylated. Highly perfectionistic, highly goal-oriented, highly regimented individuals. Anyone ever seen a child who just would, if you move the wrong way in the car, take a different pathway, they freak out, and they just have a fit until you get back on the right road? Undermethylation. Sorry, I skipped overmethylation here. Overmethylation is typically associated with high anxiety internally, depression. Now, underachievement. I want to share with you this concept of underachievement and overmethylation. It's not about the fact that these people are idiots. They're not. Overmethylators just kind of walk to the beat of a different drum. They are the laid-back, smooth jazz listening kind of people. You know, they're brilliant. They don't care about doing their homework. But they scored 99.999% on every single standardized test you can possibly think of. Harvard and Yale are calling their families until they see that their grades were horrible because they don't do their homework. They tend to be very creative. Our musicians, our philosophers, our artists, the music industry, the theater industry, all these actors we watch on TV, many of them, I'm not going to mention any names, many of them are likely overmethylated. Undermethylators tend to, as my partner would say, they tend to organize the world for us. Overmethylators tend to color the world for us. Those are the positive sides. Both have their dark sides. Next slide, please. Let's talk about zinc deficiency. Zinc is needed for the regulation of our calming neurotransmitters, GABA. Zinc deficiency is characteristic of autism, quite clearly. Zinc deficiency is also associated with ADHD, irritability, anxiety, explosive temper, violent or aggressive behavior. Next slide, please. I want to pause here for a moment. Has anyone ever heard of intermittent explosive disorder? One of the newer diagnoses in medicine. I kind of chuckled when I saw that because I said they're getting closer. It's really pyrrole disorder. Most individuals with pyrrole disorder have this imbalance of mood instability. They can become highly explosive, they can be very calm, very loving one moment. It's like your teenage daughter. Anyone with a teenage daughter ever remember when you're a teenager? Mom, I love you. Mom, my life is over. Mom, I hate you. I can't stand you. Oh, I'm in love with Jason. Oh, I broke up with my best friend. Oh, my nails are broken. My life is over. My blue jeans are terrible. All within the same day. Pyrrole disorder. If you ever want to remember what pyrrole disorder is like, think about a couple of things. A child in their terrible twos, your teenager, male or female, that's all you need to know. You'll pretty much be experts on the signs and symptoms of pyrrole disorder. Let's see, metal metabolism. There's a genetic inability to control copper, zinc, manganese, and other trace metals in the autism spectrum category. The absence of copper and zinc homeostasis or balance and severe zinc deficiency tend to be suggestive of this metallothionein issue or disorder as a problem. Metallothionein functions to really sort of include neural development, detoxification of heavy metals, and immune response functionality. Many classic symptoms of autism can actually be explained by a metallothionein defect in infancy, including gastrointestinal problems, heightened sensitivity to toxic metals, as well as abnormal behaviors. Next slide, please. Why is metallothionein important? It's required for the development of brain cells and synaptic connections. This is one of the things that we forget or may not think about too often when it comes to the structure of an autistic child's brain. Everyone develops in a very regulated fashion as far as brain connections are concerned. It's called a somatotopic development. Nerve cells start to grow from the top to the middle and from the bottom to the middle, and they meet in the middle like a good relationship, right? However, in autism, the structure of the brain is different. The cells don't quite make it to the middle, and there's this larger gap, to say the least. There's some other areas in the cortex of the brain that are structurally different as well, but we'll get to that later. Metallothionein prevents mercury and other metals from passing through the intestinal and blood-brain barriers, which is a good thing. So if you don't have appropriate metallothionein, mercury becomes a bad thing. Anyone here ever heard of mercury and autism? Just curiosity? Okay. Kind of important, isn't it? Metallothionein is important for the balance of copper and zinc, and it supports immune function. Next slide, please. Consequences of oxidative stress. The consequences of oxidative stress really mirror classic symptoms of autism. You see hypersensitivity to metals, hypersensitivity to certain proteins like casein and gluten. We see poor immune function. We see disruptions of the methylation cycle. There's that word again. Inflammation of the brain and GI tract. Does anyone here not know that inflammation is singularly probably the most important concept in all of medicine, whether it's traditional or orthomolecular? If you don't put out that fire of inflammation, your systems just are not going to recover. And that's one of the things that metallothionein promotion therapy does. Depletion of glutathione and metallothionein is another feature of oxidative stress. And then we see excessive amounts of unbound what? Copper. That creature, once again. Oxidative stress can impair brain development because it can deplete glutathione, impair the one-carbon cycle, and produce undermethylation. We'll skip this. Next slide. Consequences of oxidative stress overload in the gastrointestinal tract. Now, folks here and literally all over the world are very concerned about what's happening in the gut of children with the autism spectrum disorder, and even normal folks. We're very focused on it. Gut and Brain Psychology. Who has not heard of that book? Okay, great. What we see that's happening in the gut is that oxidative stress will destroy digestive enzymes needed to break down casein and gluten. Okay? It increases Candida and yeast levels. Who here does not know that Candida and yeast are little critters that can really mess up a child's behavior, whether they're in the spectrum or not? Okay. We had one young person who came to our clinic, 4-year-old male, who had been kicked out of 4 different preschools. How do you get kicked out of preschool? Behavior was absolutely erratic. It was absurd. It was whatever have you. After all the testing, this was done back at the original Pfeiffer Treatment Center, all the testing that had been done looked at one thing. This child was full of yeast. We corrected the yeast, and this child is doing very well. They're actually an A student at this point in time. They're in high school, doing extremely well. The singular cause was yeast. So now imagine, that's a child that can talk to you. What about a child who has autism and is full of yeast? What you see here are behavioral challenges, anger, lashing out. All these challenges are being seen, and you don't know what's going on with your child. You think it's up here, but it's not. In this case, much of it is down here, but they can't express it. So behavioral challenges are huge when it comes to yeast issues. Oxidative stress will lower zinc levels and the production of stomach acid. So for many of you who are taking hydrochloric acid of some type or another, anyone ever do that? Okay. Will you ever check for yeast? Okay. On the one hand, if the yeast is causing a decrease in the production of hydrochloric acid and you keep pouring in hydrochloric acid but you don't fix the yeast, you're spinning your wheels. So looking at yeast and dealing with the evaluation of yeast first, before pouring in acid into your system, might be a little bit more of a thorough way to approach it. Okay? Oxidative stress produces a leaky intestinal barrier allowing toxins to enter the bloodstream. Leaky gut, right? Next slide, please. Let's look at the epigenetic theory of autism, the Walsh theory of autism. There's a recipe that we're looking at here as far as autism is concerned. First of all, there's an inborn predisposition. Okay? Secondly, there's an environmental insult. And remember we said earlier, that insult can either be in the womb or after birth. Okay? Environmental insults during the first month of gestation can produce abnormalities in gene expression that persist throughout life. That's a long time. In some cases, these abnormalities can be transferred to future generations. Okay? So you see those things where somebody says, well, that boy's got his father's temper. Or, I know that's my daughter. She's been behaving like me ever since she was born. Okay? That's not the only thing that gets transferred from generation to generation. This can result in genetic increases in the number of autism-prone families. You know that most children with autism are undermethylated, right? We talked about that. One day, Dr. Walsh and I were talking, and we started talking about the idea of mating, how we meet our mates. You know, in the old days, way in the past, we were kind of stuck with regionality. You kind of married Edgar because he was the guy next door in the neighborhood, whatever have you, and you didn't venture out much. And Susie Q is cute, and you date in high school, you get married, blah, 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 blah. Well, as we became more sophisticated in life, we started going to university. We met the local girl who seemed to be just as brilliant as we were, highly intelligent, beautiful young lady from the right family, et cetera, et cetera. You decided, therefore, you're going to get married, reproduce, and then move on to your lovely suburbanite lifestyles. And then when your progeny grew up, you did the same thing. You made sure that you established the right connections with higher individuals, et cetera, and therefore kept the whole process rolling in an appropriately astute and highfalutin fashion. Well, now, let's look biochemically at what's happening. Who is it that we talked about that tends to get the good grades in high school and grammar school, and therefore gets the good colleges? A lot of undermethylators. So now we got undermethylators getting together with undermethylators, producing little tiny undermethylators. And with the right environmental insult, some of those undermethylators may be susceptible to oxidative stress and produce symptoms that can lead to autism or Asperger's or anxiety or rage or a variety of other things. That's simply one potential variable. Don't get me wrong. Don't go home and blame your spouse and saying it's your fault. I should have married the other guy. I'm not saying that. What we're saying is that there are multiple possibilities, multiple influences or factors that come into play in terms of the predispositions for autism and other disorders. Next slide. Environmental and epigenetic influences. Epigenetics, that's where you get the involvement of the alteration of gene expression due to chemical factors in the womb and the influence of environmental factors throughout life, not just that initial insult. Every cell in our body has the potential for expressing any one of 20,000 genes in our DNA. The production of gene proteins or gene expression can be switched on or switched off. In other words, silencing the gene or what we call bookmarking. Okay. These epigenetic processes are more vulnerable to environmental factors such as radiation. Does anyone not know that we've got more radiation in the world now than we did 20, 30 years ago, 5 years ago, 6 days ago? Okay. Temperature issues, dietary choices. Who's got the greatest diet in the world? The United States of America, right? Do we do anything with processed foods? Do we do anything with Coca-Cola? Anything with da-da-da-da? You guys know the drill. You guys are all health-conscious people. Health-conscious people. Any of these things are very, very important. Radiation, temperature, dietary choices, toxic metals, viruses, stressful life events. Now, viruses we cannot control. One of the most interesting things that we see in our clinic, people who travel all over the world, and they come back and they're just not the same anymore. And you try to pinpoint what happened and where, and it's next to impossible, because we had one fellow who came in, he had been to 16 different countries in literally 3 months, and he'd been exposed to everything. Now, he didn't go to the city, he went into the bush, where all the viruses and bacteria and lovely little organisms probably got together, mated, and produced new strains, so we just can't figure out what happened to them. So we're doing our best to deal with that and treat them, but virus exposure tends to trigger oxidative stress, and therefore changes in the genome or genetic expression. Attention has been focused on direct insults to the child from conception to age 3. That's where we're really sort of focusing on things right now. Next slide. Let's talk about a strategy for enhanced cognition, speech, and socialization. Number one, we've talked already about antioxidants. Powerful antioxidant therapy is absolutely necessary. Absolutely necessary. Number two, methylation protocols. But hey, wait a minute now. If you're going to have a methylation protocol, you first have to be able to identify the methylation disorder. And do you know right now that's what's mucking up a good 65 to 75% of treatment right now? People can't figure out what your methylation is. Half of them don't know what methylation is. Okay. But trying to understand it, that's why we focus on the concept of methylation and accurate measurement. Because if you can't measure it, you can't treat it. And that is a very, very important protocol or piece of the puzzle in order to deal with enhancing cognition, speech, and socialization. Biochemical therapies aimed at reversing epigenetic errors. Right now, we are not smart enough. Yes, I'm going to say it. We are not smart enough to change or fix the gene. However, we can look at what the gene is doing or not doing and try to step in and intervene in order to change what happens next. Behavioral therapies, like applied behavioral analysis, absolutely wonderful, absolutely wonderful. That helps to enhance the maturation of the brain. So you see, it's not that there's one approach here. There are multiple approaches that together shift the child into the right direction. Let's talk about metallothionein promotion therapy and biochemical interventions. Biochemical interventions and other interventions can either adjust genetic expression or they can overcome the effect of the altered gene, which is what I just said. An epigenetic tendency for high oxidative stress can be effectively treated using therapy that stimulates that protein in the brain we call metallothionein so that it can do its job more efficiently and more effectively. It is directly aimed at developing brain cells. It looks at the potential for permanently correcting the intestinal blood barrier as well as the brain blood barrier. and it restores the key healthy antioxidant system that is so necessary to keep children moving in the right direction. Next slide, please. Behavioral therapies. ABA, it stimulates organization of synapses and connections in the brain microcolumns. It promotes brain maturation that is greatly slowed down by oxidative stress and overload and inflammation. And it's especially promising when coupled with biochemical therapy. Next slide, please. So a comprehensive evaluation. How do you go about doing all this? Okay. Firstly, you got to look at symptoms. Was this individual born challenged or do they regress? You know that already. Number two, metal regulation and metal dysregulation. You know that already. Number three, environmental and epigenetic factors that you might not know, but that's what we look at. The gastrointestinal system, which includes food allergies, sensitivities, and malabsorption issues, very important. Nutrient imbalances versus dietary controls. One of the hardest things to do is to have the kind of diet that is really necessary to help move a child in the right direction. It's extremely, painstakingly difficult and challenging, and I truly applaud all the parents and all the families who go through this, because some are just absolutely fabulous, and they help the children in every way, shape, and form. Because, you know, very interesting about children, I don't know if you know this, they're not always cooperative. You want to do this, but they don't. You want to do that, but they don't. Or they tell you that they do, but they don't. When providing nutrient therapy, one of the things that we do is we have objective measures by way of testing, and we follow them sequentially. It's very interesting because you can see the trend of nutrients and imbalances moving either in the wrong direction or the right direction. So I tell families, and I tell teenagers especially, I can tell if you're cheating. You can't lie to me, because I can see it in the work, in the charts. And family members will say, well, you know, I know he takes his supplements every day, but I've noticed the dog's hair is looking really, really good. The plants are growing really, really well. But my son says he's doing well. And I say, well, ma'am, well, according to this, your son is going for a crash. And sure enough, 1 or 2 months later, it happens. Okay? So, gosh, I get off track. I'm so sorry about that. So in our evaluation, GI issues, malabsorption, nutrient imbalances, yes, dietary control. Testing for methylation. Once again, very important. Pyrrole disorder. Zinc and B6 imbalances. Next slide, please. So our overview of treatment. As in any clinic, you've got to do a physical examination. You've got to lay hands on this person. You have to see them. So much is gained from observation and actual manipulation structurally. That can't be done over the internet. That can't be done by Skype. I'm sorry, you can see someone in 2 dimensions in Skype. You don't see the pimples and all the other stuff that suggests yeast. You don't see the structure that's contorted. You don't see how a person carries themselves. You can't really tell if they're an over or undermethylator. By the way, undermethylators have a particular body type, and so do overmethylators. In fact, so do pyrolurics. I'm not going to tell you who those people are. Keep that one to myself. Okay. Oh, okay, you twisted my arm. Undermethylators tend to be more long and lean. Overmethylators tend to be thicker, a little bit more solid, a little bit more muscular. Pyrols tend to be oftentimes a little bit more pear-shaped. Okay. It's funny because my partner and I, Dr. Bowman, will walk through airports, and I don't want you guys to get paranoid because we're close to a hair. We'll be going around, and we'll go, oh gosh, undermethylator, oh, overmethylator, oh my, pyroluric, real bad. Oh, that's copper toxicity. Oh, that person looks like they're from Ireland. That's a serious pyrole. Once I almost walked up to a lady, I almost said, ma'am, it's going to be okay. I could just see it on her face. Severe pyroluria and copper toxicity was just highly evident. So we can't determine that, though, if we don't see you. And I'll just share something with you, a little tidbit. There are 2 genetic historical background categories, ethnically, where you see most of the population is just pyroluric. Number 1 is the Irish. Number 2, Scandinavians. Now, I know no one in this room could possibly be related to an Irish or a Scandinavian person. Being facetious, of course. But the little redheaded people that we see walking around the place, and I mean the children, not short people, Scandinavians as well, have a propensity to be susceptible to pyrols and pyroluria. As a matter of fact, when we really sort of sit down and think about it, what is the stereotypical Irish person like? According to the media, the cartoons, and all the fun stuff, not in reality. You've got the guy who's sitting there in the bar who's ready to fight at the drop of a moment. All it takes is you saying the wrong thing, and boom, the bottles break, the hands go flaring around, and fights break out, and da-da-da. fiery, temperamental, or one fellow says to his friend, hey, whatever happened to you and that fiery redhead, the Irish girl, that girl with spirit? Okay. Well, you two got together and had little pyrols running around all over the place. Okay. So we know from history that there are going to be certain susceptibilities to biochemical challenges. Okay. So very extensive patient history is important. Specialized laboratory testing, then prescribed individualized nutrient therapy. We don't do things in a general level. It's very targeted to the individual person. It involves vitamins, minerals, and amino acids, usually at much higher concentrations than you see in the RDA levels. And that's when most doctors freak out, like Scotty from the Enterprise. Oh my gosh, you've got 30 milligrams of zinc. You're going to explode. No, that's nothing for an adult. Now, don't go doing this at home, okay? Talk to us first. But very high concentrations. You have to overwhelm what the genetics have done, okay? Looking at GI issues, gastrointestinal issues, prebiotics and probiotics, digestive enzymes, antifungals, natural chelation. That word natural comes first. Advanced gluten, casein, and food allergy issues, dealing with them, avoiding those things. And then determining a patient's dietary requirements based upon methylation status. That's one of my favorite things to do right now. I love telling people, so you think your vegetable diet is helping you, do you? Well, how many of you know that if you are an undermethylator, vegetable diets are not going to be helping you very much? In fact, they're worsening your methylation status if you've got a mental health condition, not the general population. You guys thought you were doing well, right? I eat real well, I eat real healthy. That's what I hear a lot, and I say, well, wait a minute. What does that mean? Health and wellness, from a dietary perspective, are dependent on who you are as an individual. The question I hear so often is, well, Dr. Mensah, what's a really good diet? And the first thing I say is, well, the first question to be answered is, who are you biochemically? We find out who you are biochemically, then we can tell you what the best diet is for you. Because I can guarantee you, if you got an undermethylator in the family and an overmethylator in the family, the best diet for either one of you is not going to be helping the other person. And you guys can mellow out somewhere in the middle, but that's a whole other topic. Next slide. So Mensah Medical, our main clinic is 25 miles west of Chicago in Warrenville, next to Naperville. We've got outreach clinics in Fort Lauderdale, Florida, Garden Grove, California, Annapolis, Maryland, Burlingame, California. We tend to cycle through these places twice a year. And next slide, please. Thank you very much. Time for questions and hopefully some answers. Oh, what happened to our microphone? Oh, okay. I'm going to ask you folks to just come on up here to ask your questions. Okay. And go right ahead. I'll just back up this way.
It's a little high.
Oh, let's lower that for you.
That's okay. That's okay.
Take it out of the. Take it out of there. You don't
yeah.
have to tippy toe. It's not.
Yeah.
We're doing your. Great.
Okay. That was great. Thank you. I had a question about natural chelators because
Yes.
one of the things my doctor has recommended is down the road, a couple months from now, he wants to start doing IV chelation with my son. Mm-hmm. So I just wanted to know, what your thoughts are about it. It seems like you were going towards the don't do it side versus, do it naturally. And, another one I've been looking into is also Andy Cutler's chelation as well, which is a gentler approach to it, probably a little bit more labor-intensive as far as doing it at home as a parent. So if you could speak to that, that would be great.
Absolutely. When we talk about natural chelation, much of what we're doing is looking at how nutrients in and of themselves can remove certain metals or balance certain things. We talk about selenium. We talk about elements that I won't mention because I know you guys are going to want to go home and do it, that kind of remove copper. We talk about, but most importantly, the stimulation of metallothionein, the body's own regulatory system to help remove and regulate metals. It will not strip you of the good metals that you've got. It will get rid of the bad. It is a regulator. Okay. So in that sense, you're not going to be losing out on the positive metals. When you do that traditional chelation thing, especially the IV chelation, you're losing calcium. Do you know how important calcium is? It's not just for bones and growth. Calcium regulates muscle contraction in your heart. It regulates all sorts of things on a cellular level. You cannot afford to be stripped of these good metals while you're trying to get rid of the bad ones. The other side of the issue is that IV chelation and those chelators really don't do what we think they're doing. Because we believe that metals are the problem. It's not the metals, it's the inflammation that the metals have produced. That's the problem. So mercury, who here thinks mercury is a problem? Okay. How long do you think mercury actually survives in your system at an active level? It's less than 3 months. Active mercury is dead. If you're thinking about removing the mercury you've had in your system for 3 years or so, you're barking up the wrong tree, quite honestly. However, the inflammation that that mercury caused, the oxidative stress that that mercury caused is still in play. So while you've been a good person, removing all the mercury, removing all the toxins, removing all those things, if you haven't dealt with the oxidative stress or the inflammation, you haven't really done yourself a favor, okay? So you've got to deal with the oxidative stress, and that's one of the things that the metallothionein promotion therapy will do. It'll deal with the inflammation, the oxidative stress, and handle the metals.
What exactly is it? Is it herbals? Is it,
No, it's not herbals. It's a prototype of minerals, vitamins, and amino acids that stimulates that protein we talked about called MT. Okay. We do not do chelation of a traditional variety. We do what we call natural chelation. In other words, we stimulate the body's own system of regulating metals, and it works well. Okay. Yes, ma'am.
Okay, 23andMe, okay,
Yes.
you get the information, your child has the MTHFR defect. Okay, so that's telling you that there's a gene there, but we don't know whether it's being switched on or off. Okay, so now you're going to a doctor, and he's saying, okay, take, MTHFR. He's a big Ben Lynch fan. So we're doing that, getting methyl B12 injections. My son is a patient of yours, and I know what you're...
I wasn't going to tell.
I know, there's a controversy going on between Bill Walsh. I just listened to Ben Lynch, and he's saying you shouldn't be taking the MTHFR every day. It should be in very small doses. So he's looks like he's evolving his theories about this. Ben Lynch, So can you kind of clarify again, once more, if your child is undermethylated, can we be supporting them with any kind of methyl, either methyl B12, methylcobalamin, or?
Well, you're asking really 3 different questions. I'm going to start with the last one first. If your child is undermethylated, that's exactly what they need, methyl. Here's the problem. Where do you get it? The presumption is that folic acid or methylated folate is indeed what it is your child requires. Now, I'm going to put it to you this way. I want you to think of methylated folate as a double agent. Okay, anyone here seen James Bond? Okay, that lovely female that he's always with, usually a double agent. Methylated folate in one part of the cell is a wonderful donor of methyl. On the other hand, once it dives into the nucleus, it actually steals methyl, okay? So now, for the one methyl that it gives, very generous, here's a methyl for you, ma'am. Over here it's saying, can I have 10 methyl, please? And it takes it away. So it functionally makes your undermethylation worse. That's why we use elements like methionine and SAMe and TMG and DMG as our primary methylating sources. It gets much more complicated, involving neurotransmitter regulators and uptake mechanisms, but that's how I generally want you to think about it, okay? The problem is that when you're dealing with methylation challenges, you take methylated folate, most children will get worse. Now, that's in general mental health. In the autism spectrum, it's a little bit different, okay? 30% of those children will respond better to certain things like folinic acid and so forth and so forth. But it's very, very individualistic, and the issue is really one of cause and effect. We see that overall, children who are undermethylated in the spectrum do not do well overall on folic acid. Now, here's the difference. Ben Lynch is a very brilliant person. Dr. Yasko, an amazingly brilliant person. And everyone has their protocols. We cheat. See, before this whole thing about methylation was let out of the bag, we've been doing it for over 30 years with good results. So we know the end result, which is you don't treat these kids with that, okay? We've seen it already. So discerning what the mechanisms are internally that move you from point A to point B, that's where everyone's getting a little bit confused. Because they're looking at certain pieces of the cycle, and their belief is that that part of the cycle is what's key in influencing all the other aspects of methylation, and it's not. That's not how it actually works in life. Maybe in the laboratory, the test tube, but not in actuality in life. So, what do we say? Treat the undermethylation with proper methylating agents. SAMe, DMG, TMG, methionine. Folic acid is typically for the overmethylators, okay? Because it does remove methyl, okay?
Thank you.
Great question, though.
Hi, my undermethylator grandson will be happy to know that veggies are actually not that great for him.
He still has to have some. I'm not saying you don't need any. Okay, still need some.
My question is, what is a good diet for an undermethylator?
That can take a long time.
Yeah.
What we
General
say is that
minds.
you want to minimize, here's the thing again, for an undermethylator, you want to actually minimize diets rich in folic acid. So your dark green leafy vegetables in huge concentrations are not what you want to do. I often tell most people, you don't want to become a vegetarian or a vegan, don't shoot me, okay, if you are a classic undermethylator with cognitive challenges. I'm not talking about the average person walking down the street. They can pretty much do whatever they want. When we've got these cognitive imbalances and cognitive challenges, you got to be careful. So it's not so much what you do, it's what you don't do. You want to avoid high concentrations of the folate-rich foods. And you can Google that. That's
Thank you.
Mm-hmm. Yes, ma'am.
Hi. It's Haya. I was wondering about, you were talking that Asperger's and autism
Yes.
are different and not part of the same continuum?
Absolutely.
Okay. My son's high functioning, autism, PDD, NOS,
We don't
kind
know.
of
Yeah.
Asperger-like. So where would he fall? I mean, would he?
I'd have to see him.
Okay.
Because you said three
What's the
very
difference?
distinct things. You talked about autism, PDD, NOS, high-functioning autism. You said four things. Then Asperger's, they're very different. Okay. The Aspergian, as they call them, Aspergians, tend to have very little capacity for creative thought and creative understanding in the sense that you tell them a joke, they may not get it.
Okay.
Socially speaking, they're more isolated. Okay. And the most important thing is intellectual
Yeah, he's
capacity.
more social.
The most important thing is intellectual capacity, as far as I'm concerned, as far as delineating what is Asperger's from any other syndrome. The kids who have Asperger's are usually very bright. They will one day become your manager. Okay, they may own the company. I honestly think texting was developed by Aspergian people. They don't have to directly deal with anyone. Okay, emails. You don't have to directly deal. You don't have to communicate. You don't have to share. That's a major part of the issue with regard to Asperger's. Okay. The only other way would be to look into the brain itself and the brain structure. Okay. Aspergians have a very different brain structure than kids with autism, except there's some similarities as far as weaknesses in the blood-brain barrier. We see that very commonly in the area of the cerebellum. But it's a very individualized question. We would literally have to see your son and do a much more thorough history and evaluation to determine that.
So the stuff you were talking today is in regards to autism rather than Asperger's?
Autism,
I mean,
yes.
do you do a completely different
We
talk
do
for
a
the
different,
Aspies?
we do a different treatment, a different talk for Asperger's than autism, because
Okay.
they are different creatures.
Okay.
And we were actually one of the first to say that.
All righty.
Very
Because you don't usually hear that.
No, well, let me tell you, bottom line is this. Children who are on the autism spectrum have a neurodegenerative disorder. They will get worse over time unless you intervene. Asperger's children will continue to evolve and do well intellectually. How can those two be the same? Their brains are also structurally different, thanks to Dr. Walsh's evaluation of brain structures. He's got the world's largest database on the brain structures of autistic children.
Okay.
And actually, the National Institute of Health uses his work as standard.
Okay, because it seems that the reason that he was diagnosed as PDD NOS rather than Asperger's was because of a speech delay.
It's actually because they don't know.
Okay.
Every
I
time
mean,
I hear that, I'm like,
nothing was
okay,
looking,
they didn't know. It's PDD NOS,
Yeah.
until proven otherwise. Da-da-da-da.
Yeah.
Thank you very much. ma'am.
Okay, thank you.
Yes, sir. The short gentleman right here.
Yeah, in reference to some of the tests that are needed to measure levels in our children, our daughter is going to be 3 in July, so we're facing a few challenges. Number one, not anywhere near potty trained, so question about the urine test. Yeah. Number two, with 23andMe requiring that level of saliva, big challenge there. Are there any alternatives to that with perhaps just a swab? And then number three, the blood test. Is one blood
Dr.
test...
Bowman. Dr. Bowman, come up here, please.
Is one blood test sufficient to capture many of these measurements, just given the trauma that could cause?
I'm going to have my partner. She likes to sit quietly most of the time. Dr. Judith Bowman, everyone, Dr. Judith Bowman.
Okay, in terms of testing, there is a blood test, there's a urine test, and very often there's also a hair sample. So the hair and the urine sample are pretty easy to get, even if you have to have other methods of acquiring that, meaning that put a little hat in the toilet or actually a device on the child to collect the urine.
Sorry.
Well, that's okay.
My apologies. We have to move forward with our next presenter. But if you'd like, maybe you can continue to answer questions outside.
We'll be meandering outside if you have any other questions.
Absolutely.
Thank you very much.